Hi there, I'm Jonah Nickfon, and this is my Physics 2 Lab 5 analysis. So for the introduction, the purpose of the lab was to understand Faraday's law and induced currents and to use GlowScript to model physical events. In the lab, we passed a bar magnet through a aluminum foil roll to create an induced EMF in the roll so that it creates a force opposing the gravity so that the magnet falls slower through the tube. And the physics ideas present are Faraday's law and the Biot-Savart law. The preliminary results are that it took about 1.12 seconds for the bar magnet to pass through the foil. And our assumptions were that there is no friction and gravity is equal to 9.81 meters per second. In the experiment, we first found the north pole of the magnet, then recorded how long it took for the magnet to fall through the tube, and then averaged that to find the average time taken through the tube. The data, we found that the magnet mass was 0.243 grams, and with that we were able to calculate the magnetic mu constant, the tube width. Well, we just found the tube width and the rolled radius, and then we have the average fall time as well. So for the coding, we first inputted constants, if you can see up here, and then we inputted our variables for the problem. So I inputted my length, the width, and the inner radius of the tube. And then we also inputted on line 65 the mass of the magnet and the mu of the magnet. And then we created a function to calculate the B field of the magnet. The program continued. After that, we created a function in the top to calculate the flux, or the change in flux, and then we used a while loop in this big chunk of code to sum up all of the forces over the entire time, and this returns the net force and then updates the velocity of the magnet through the tube. The GlowScript results were that it took 1.146 seconds for it to pass through the tube, and in the observed results, it took 1.12 seconds, so there was only a difference of 0.026 seconds, which is very close. So I think we did a good job there. And then in the graph, we see that the acceleration initially decreases because at the start, because the magnetic force from the induced current acts upwards against the force of gravity. And then while the magnet is in the middle, we see that the velocity is fairly constant, so that means that the force of gravity is equal to the force of the magnetic force. And then we see at the bottom it is red, and this shows a clockwise current, and so yeah, for the what if questions, what if the resistivity of the conductor were as close as possible to zero? How would the dynamics of the falling magnet change? The induced current would approach infinity, and therefore the force of the magnet would be enough to make zero velocity throughout the tube. And if there were holes or slots cut into the tube, then the current would decrease as sections of it are broken off, resulting in the magnet falling faster throughout the tube. Thank you very much. I am Jonah.